Hello viewers, in this video lecture we are going to see one topic from the first unit of Theory of Computation. The topic is Finite Automata, and the objectives are to understand the concepts of finite automata and to analyze the types of finite automata problems. First of all, let us see the introduction about the finite automata. Finite automata is the machine which is used to recognize the patterns. Finite automata means it consists of finite number of states. So it is called as finite state machine. Okay. So this machine consists of the operation of the machine has been considered with 5 elements or 5 tuples. So the system or the machine will do one specific application or it will solve one specific problem. The course of operation of the machine will be considered as the set of states. So we can say the machine will solve the problem by undergoing some set of states, and it will follow some rules to move from one state to another state, and the state change will be depend upon the applied input symbol. Basically, it is an abstract model of a digital computer. Now we can see the basic structure of the finite automata. The automata is the system finite control machine which will perform its operation by using some states, different states of operation. The states are called as Q1, Q2 up to Qn, n number of states, and there will be the input memory. Input symbols, sequence of input symbols will be applied to the automata so as to perform its task, and by consuming the input symbol the system will change from one state to another state. This is called the state transition, and corresponding to the input symbols the system will produce the sequence of output symbols. The outputs are considered as O1, O2 up to On, etc. So when we say the features of automata, the automata has 5 features: input, set of input symbols, output, set of output symbols. States of automata, state relation. State relation means can be otherwise told as state transition. That will represent how the system is changing from one state to another state. So the state transition function is the 4th feature. And 5th one is output relation, which is nothing but the sequence of output or set of outputs. And formally we can define the finite automata with the help of 5 tuples. We will represent it with the help of 5 symbols. Q is finite set of states, and sigma is the set of input symbols. Small letter q is initial state. So small letter q belongs to capital letter Q. Capital letter F is the set of final states. Some system may have a single final state. Some other system may have more than one final states. So we will tell commonly set of final states. And delta is the state transition function. So we can define any finite automata machine with the help of these 5 features or these 5 tuples. Now we can see the types of automata. The automata machine can be divided into 2 types: DFA, deterministic finite automata, and NFA, non-deterministic finite automata. Let us see the features of deterministic finite automata. Deterministic means it refers to the uniqueness of the computation. That is, system will move from one state to another state by consuming a fixed or a particular input character. And another one important feature is in deterministic finite automata, the system will not perform the state transition by consuming the null symbol. So when we represent this kind of systems, we will use 2 methods for the representation. They are the transition diagram and the transition table. First, let us see the transition diagram. For transition diagrams, transition means state transition, that is state change. While performing the operation, the finite automata system will move from one state to another state. This is called a state change and state transition. So the transition diagram will be represented in the form of directed graph with the vertices of a graph. uh, Vertices of the graph corresponds to the states and edges indicates the transition from one state to another state. In this diagram, we have one diagrammatic transition diagram for some automata system. By seeing this diagram, we can understand different states are represented with the circles, small circles. Inside of the circle, the state is represented, that is q0, q1, q2. Here q0 is the starting state, and edge from q0 to q1 represents the edge having the label 0. It represents by consuming the input symbol 0, the system is changing from q0 to q1. In this way we will represent the state change, and the q2 having the double lined circle, which will represent q2 is the final state. So we will write each state transition as the state transition function delta. So we can write the state transition for the first change q0 to q1 as del of q comma del of q0 comma 0 equal to q1. Common format is del of q comma a is the p. That means while applying the input symbol a to the state q, the system is producing the new state p. Okay. So in the state transition diagram, the edge will labeled with the input symbol that is needed to perform the state change. Next one is state transition table. This is the tabular representation of the delta, that is the state transition. Here the rows will represent different states like q0, q1, q2, and the columns will represent the input symbol. Now we are having the state transition table for the diagram, above diagram. We can match the diagram with the table. In the table we can see q0, we have to list out the original states q0, q1, q2. Inside the cells we have to represent like this: AB q0, while applying A to q0 we are getting q1, while applying B to q0 we are getting q0, the same state. So in the diagram we can see there will be the self loop from q0 to q0 by consuming the input symbol B. And we can say another one example, q1, when apply B to q1 we are getting q2, and so on. In this way we have to represent the automata system, deterministic automata, with the help of the transition table. And we can also see the common features of non-deterministic finite automata. So we can understand the features of both DFA and NFA by differentiating them. In DFA, each symbol causes a move. In DFA, each symbol, as a result of the consumption of the each symbol, the system performs the state change. It is deterministic. And one more thing is, in DFA the next state is completely determined by the current state and the current symbol. But in NFA there are some more different features, like the machine can move without consuming any symbol, or sometimes the machine consume more than one symbol during the same state transition, and sometimes there is no possible moves and sometimes there are more than one possible moves for a symbol. And also NFA perform the state transition without consuming any symbol. So that's why this kind of systems are called as non-deterministic finite automata. But deterministic means there will be a specific symbol, everything is determined, that is for every simple consumption, system definitely will do the state transition. And we can say every DFA is NFA, but not DFA is, but NFA is not DFA. And another one thing is, in both NFA and DFA there can be multiple final states, that is one common feature. And DFA is used in lexical analysis and NFA is used for theoretical concepts. Now we can see the important university questions that can be asked in this topic. Explain the concepts of finite automata. differentiate DFA and NFA, explain the types of finite automata. Thank you.